Growing up, I liked playing with instruments, but due to the lack of them in my country, I don't have them. But the one special thing that we had in our hands available was a traditional instrument called karar. This instrument has some similarities with the guitar, but their musical tones are kind of different. So, what does string theory have to do with your traditional instrument? Let me take you a little back to the 20th century, when the two revolutionary theories in physics emerged. Quantum mechanics and general relativity describes physics on astronomical scale and models gravity as a geometric property of spacetime as it works in the presence of mass and energy. Whereas quantum mechanics describes physics on a scale on which gravity appears insignificant. And for years, physicists have suggested many ideas to reconcile these two revolutionary theories by describing gravity according to the principles of quantum mechanics. The most popular theories of quantum gravity is called string theory. Okay, keep going. The idea of the most basic building blocks of matter stops at the standard model of particle physics. This theory says that every matter in the universe is made up of quarks and leptons through the exchange of force carriers called bosons. The string theory comes along and states that within every of those elementary particles, there is a tiny vibrating string. Strings are so tiny that if magnified to the size of the solar system, the string would be the size of a tree. So the reason why traditional instruments sound different from the guitar is that both vibrate at different frequencies. The same analogy applies to the particles as well. For example, if a string vibrates in one way, an electron. If it vibrates some other way, we see a quark or a photon. Therefore, string theory solves some of the problems quantum mechanics can. Very importantly, predicts a hypothetical particle that carries the force of gravity called graviton. Unfortunately, there is no evidence that gravitons exist, so string theory runs into many problems. One of them is its inability to make any proper testable predictions about the real world. So maybe someday, me or you watching this video might become a physicist and be able to find evidence that gravitons do indeed exist, as well as that string theory is still the best approach theory of everything. Thank you.